Greetings to all of this team Helios from Indonesia, and today we present to you the Solectrify. Our solution will touch upon the renewable energy category, and it is also equipped with the solar tracker, the hybrid battery system, as well as the sliding system. We hope you enjoy the presentation.
First, we will address the problem our overdependence on fossil fuels have resulted in greenhouse gas emissions running rampant over the years. As a result, extreme weather events and health issues has been rapidly increasing, and without a doubt, fossil fuels are one of the main contributors of global warming and climate change. But we have a solution. Our solution is to develop a renewable energy system that we will be able to store and wirelessly charge electric cars.
So this is where our Solectrify comes in. The Solectrify can be divided into three main sections. The first section is a solar tracker, which harnesses energy from the sun and produces electricity accordingly. Furthermore, it's also equipped with the hybrid battery system, which is able to take input current from the solar tracker and eventually supply current to the system when it is needed. Finally, the highlight of our system will be the sliding or the wireless transmission system, which is able to wirelessly charge electric cars in parking lots.
First, we will address the purpose of the solar tracker. The solar tracker increases direct exposure to the solar rays, thus generating more electricity than a general stationary counterpart. The difference between stationary solar panel and a solar tracker is the increased efficiency of the latter, as it is able to track the course of the sun through the use of light-dependent resistors, measuring the light intensity accordingly. As you can see, a solar panel will not be able to maximize the output energy collected from the sun, as the sun is moving throughout the day.
Getting to the specifics of the system, the solar tracker will be divided into two main sections, the tracking mechanism as well as the rotary mechanism. The tracking mechanism consists of four light-dependent resistors, which are able to measure the light intensity of the sun and eventually track the sun accordingly. Furthermore, it's also tied in with the rotary mechanisms, which consists of the 17HS6401 stepper motor and the 17HS6601 stepper motors, regulating the X and Y axis of the solar tracker accordingly. Furthermore, it's coupled in with the timing belts and different size gears in order to increase the gear reduction ratio of the system. To create the frame of the system, we'll also be using the aluminum profile 6063 T5, the L connectors, the M5M4 bolts, the T-nuts, the shafts, and the bearings of the system.
The hardest energy of the solar tracker would go to the hybrid battery system, particularly the lead-acid battery. The lead-acid battery will store the output energy from the solar tracker and to supply the current to the system when needed. For example, the energy could be used to charge electric vehicles in parking lots, as well as rotate the solar tracker on days where there is little to no sunlight. This focuses the scope towards the wireless charging system. Electric cars do not directly produce greenhouse gas emissions and is one of the fastest growing models in the automobile industry.
With the immense growth prospects electric cars have been boasting over the past few years, electric cars will be the best alternative to diesel-powered transportation, which emits much greenhouse gas emissions. Thus, we have decided to incorporate a wireless charging system right here in parking lots to charge electric cars, especially since electric cars do not produce greenhouse gases directly. So it can definitely be useful when families are out shopping with their families, or possibly when they're out waiting in parking lots. So it takes the implementations of electric cars a step further in the automobile industry. The wireless transmission system utilizes the 17HS6401 stepper motor, the timing belts, the gear-to-gear system, as well as the four smaller IR sensors, which are able to detect and stop at its own place, the wireless transmitter, and the wireless receiver of the car.
We will discuss how the wireless transmission works. Two larger infrared sensors will detect the general direction of the vehicle. If the right infrared sensors detects a vehicle, the stepper motor would rotate the wireless transmitter to the right and vice versa. The only question would be how to stop the wireless transmitter and receiver exactly in place. This is where we 3D printed two latches for the wireless transmitter and receiver. On the side of the 15 by 15 centimeter latches, there are four smaller IRs that will detect a digital value of 1 or white, and will stop if all four IRs sensors detect the same value.
With solar technology growing exponentially efficient, it is simply a matter of time before solar trackers make its far-reaching step into the renewable energy industry, lessening carbon emissions and improving the global climate situation. Moreover, the unlimited growth capabilities that wireless charging technology is boasting over the past few decades are simply going to show that we are shifting from an era of diesel to electric-powered cars. Thank you.